Hi guys, here's video 4-4 for the weekend of Friday, December 2nd. The homework that corresponds to it is page 8, number 1. And I filled out this chart already, right down here, but I think that you should pause the video and fill it out yourself real quick, and then make sure that you got the same things as me. So pause the video now, and then fill out, fill in all those blanks. Okay, and now hopefully you paused it and did that. These are what I got. All right, so compare and make sure that we have the same things. Now, as you're comparing, I'm just going to say a little bit about like the reasons why these are the answers. The critical numbers are where this is the I should say first that this, you could be looking at a derivative graph. I should have said that this is the graph of f. Okay, so this is the I'll just say original graph. Okay, so that's the graph of an original function. The critical numbers are where its derivative is 0 or undefined, so these values. Relative maximums are going to be points that have the highest, or they're going to be highest y values within like an interval on the graph. Minima, lowest y value within like a certain small interval close to the point. Endpoint outputs, and the reason why we find the endpoint outputs is because when we're determining absolute maxes and mins, the highest and lowest points overall, not just within in a neighborhood around them, but overall, then you have to take the endpoints into account. At no other time do you take endpoints into account, only for absolute maxes and mins. And it turned out that this was the highest y value overall, this was the lowest y value overall. This was not an endpoint, this was. So this one was also a relative maximum. Inflection points right there because there's changes in concavity. Okay, so that was just a little exercise, but this is what we're really studying today, and it's something called the first derivative test. If c is a critical number of f, and f is increasing to the left of c and decreasing to the right of c, so try to imagine that, then f of c is a local maximum value. Okay, so if you're increasing to the right, increasing to the left, decreasing to the right, you'd hit a maximum. And down here, guys, this picture just shows you all of that. So increasing to the left, decreasing to the right, you'd hit a max, local. Decreasing to the left, increasing to the right, you would hit a minimum. Okay, so this is the first derivative test. Okay, I didn't read the rest because the rest of it is just the reverse of what I said the first time. Now, when to use this test and how it works. When to use it: to find relative/local. I say relative/local a lot, just they mean the same thing. I should probably just stick to one. Okay, but relative/local extrema, maxes and mins, and intervals of increase and decrease. How it works: you find the critical numbers and test points to the left and right. And that might not be clear what I mean there, so we're about to do an example and you'll see what I mean. All right, find critical numbers. Actually, you know what? Test points to left and right. Let's add something here. Okay, and look for sign changes of f prime. When f prime changes sign, that's when the original graph will have a maximum or a minimum. And I think I showed this in maybe the last video, and I'll put it on the board for you soon. This wonderful teacher that I met over the summer named Susan, she has her AP Calc students memorize this table here. I think she has like 100 and some students, and like 90 of them got 5s, so on the AP test, which means they really, really know calculus. So she has them memorize this. So f is increasing when f prime is positive. F is decreasing when f prime is negative. So you know that you have an extrema of f if f prime changes sign at a critical value. So this part here, we'll talk about the rest of the chart later, but this is what we're going to be using in just a moment. Okay, so let's flip to the back. I'm trying to make this video shorter than I had like a 28-minute one the other day, which was obnoxious, but also fun to watch. Come on. Okay, so now part D we're going to cross out, and part E we're going to cross out. Okay, and I'm also going to add explain. Okay, so I would like you to we're going to explain these things as well. Okay, so for the function below, find the critical numbers. So A, the critical numbers are where the function is 0 or undefined. All right, so I'll go like this. I'm just going to be super, super careful with my work, and I'm going to communicate very well to my reader. So I'm going to say f prime of x equals 0, then x squared minus x plus 4. Oh, crap. I have to find the derivative first. I'm sorry, guys. I'm not going to start over with the video. I'm just going to, okay, just forget what I just did. The critical numbers are where the derivative is 0 or undefined. So I have to find the derivative first. So I need quotient rule. Go at your own pace here, so go faster than me if you'd like. I'm using the quotient rule, so the derivative of the numerator is 2x minus 1 times the denominator minus the numerator, x squared minus x plus 4, times the derivative of the denominator, which is just 1, and then this is all over x minus 1 squared. Okay, now I often tell you not to simplify, but when I say that, I'm talking about your final answer. This is not the final answer, this is just a step in getting there, so we've got to simplify this, because otherwise it's going to be hard to figure out the critical numbers. So, you know, when I say not to simplify, I mean final answers. You'll often have to simplify along the way to get the final answer. Okay, now guys, this is just algebra right here. So what you have to do is you have to, you know, distribute up here, combine like terms, and then you end up with a quadratic, which you will have to factor in order to see where the numerator is 0. Wait just a second. What did I end up with? All right, I'm looking at my notes from earlier. Okay, I'm just going to kind of jump to the end. So I am skipping a lot of work right here in the interest of time. Okay, you should do the algebra, guys. Okay, to make sure that you end up with the same thing as me. And to make sure I didn't make a mistake, because I'm looking at my notes from a few days ago. So this is what I got when I distributed combined like terms, got a quadratic, and then ended up factoring it. And you don't have to factor it really at this moment if you don't want to. Well, actually, I think that you should, because we're going to have to look for a sign change here, and it'll be easier if it's factored. Okay, so that's what f prime is. So part A, the critical numbers are going to be where this is 0 or undefined. It's 0 when the numerator equals 0. So we've got x equals 3, x equals negative 1. And it's undefined where the denominator is 0. So x equals 1. So these are the critical numbers here. Now, part B. Determine and state the intervals on which the function is increasing and the intervals on which it is decreasing. So if you remember Susan's table, the function is going to be increasing where the derivative is positive, decreasing where it's negative. So this is what we're going to do. For part B, you're going to do an f prime number line. Okay? These represent values of f prime. You're going to divide the number line with the critical numbers. So negative 1 and yeah, so we've got negative 1, 1, and 3. And what I'm going to do is, okay, so let's put, I'm going to put like points here. And I'm going to say for myself, for future reference, what f prime is like at these x values here. Okay, so for negative 1, it was 0, right? So I'll put like a little 0 up there. At 1, it was undefined, so I'll put a little u there, and at 3, it was 0, okay? Now, at these points, it's neither increasing nor decreasing, the original function, because f prime is neither positive nor negative. So we have to pick points within these four intervals, and then test them in the derivative and see if the derivative is positive or negative. So I'll do, if 0's in the interval, you should choose that. 0's not in that interval. So let me test -2 over there. I'll test 0 here. That'll be my testing point there. I'll test 2 there, and I'll test 4 there. You're going to plug them into the derivative and see if it ends up positive or negative. So if you plug in -2, you end up with -5, -5, -1. So a negative times a negative is a positive. And then down here, you'd end up with -3 squared. So you also get a positive. And guys, this is a good observation that I'd like to make right now. This denominator is squared, so it's always positive. No matter what, whether a positive or negative number ends up in the parentheses, we're squaring it. So the denominator will always be positive. So this first interval, we get a positive over a positive. So that's where f prime is positive, which would mean on that same interval, f is increasing. Now, here I'll plug in 0. When I plug in 0, I get negative times positive, which is a negative. Again, that's always positive. So negative over positive would be negative. So f prime's negative on that interval, which means f is decreasing. Plugging in 2, we get a negative and a positive. So a negative, or that's going to be another negative. So there was no sign change here, guys. Sometimes the critical numbers are not going to represent any extrema. All right, there was no sign change. And then I plug in 4, and I get positive, 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 so positive there. Okay, so what they were asking in part B is where f is increasing or decreasing. So I'm going to say increasing wherever f prime is positive. So f is increasing, so f is increasing on 2 intervals, -∞ to -1. Don't include it, because at -1 f prime is 0, which means, and 0 is neither positive nor negative. So f would be neither increasing nor decreasing. Union 3 to infinity. Now I added this explain. So why is f increasing there? F is increasing there because f prime is positive on these intervals. Okay, now decreasing. Go ahead of me, guys, if you've got the idea. So f decreasing where it's negative. So I've got 2 intervals here. Yes, okay. So I'm going to have a union of 2 intervals, even though there's just that one point that's sort of interrupting these negative sections. Since the derivative's undefined there, we can't say, it's not negative, it's just undefined. So we can't say we cannot say that the original function's decreasing. I'm pretty sure. Okay. I'll come back to that. I'm pretty sure it's supposed to look like this. From -1 to 1. Let me talk about that in class. And I'll do some research. Union 1, 2, 3. I'm pretty sure it looks like that. Okay. And then this is because f prime is negative on these intervals. Okay, now part C. Part C. Find and state the relative extrema of f. Okay, so relative extrema, and I'm not asking you whether they're maxes or mins, but in our answer, let's say that. Okay, so we know that we've got extrema of f when f prime has a sign change. Okay, so I've got a sign change here and then we've got another sign change there. Okay, this sign change goes from positive to negative. So positive to negative, so this would be a max. This sign change, negative to positive, negative to positive, that would be a min, okay? And you could even use your transparency. I actually had this idea earlier. Okay, so on this interval, we've got a positive slope for the tangent line, this interval negative slope, so it would go like this if we were moving it along the graph, so max. There we'd have a negative to positive, so if I was moving this tangent line along the original F graph, it would go whoop like that, so minimum. Alrighty, so for part C, I will say, and remember we're saying Y, F of -1, oh, but we've got to plug it back in. Okay, F of -1, I haven't done this yet, equals, okay, so if we plug -1 in up here, what we get 1, I'm sure you're faster than me at this, we get 1 plus 1 plus 4, so we get +6 over -2. I think that's -3. Please comment under the video if I'm wrong. I'm pretty sure that's right. Yeah, because we get, yeah, I'm pretty sure that's right. Yes. Okay, so this is a local max. You could say relative if you want. Local max because Y, F prime changes from positive to negative, and then we're just going to have F of 3. We have 9 minus 3 plus 4. So I think we get 5. 5 is a local min because F prime changes from negative to positive. All right, guys, so there's that. You only have one example that's like this. And guys, I just want to point something out. Notice how the max, the local max, its value is lower than the local min, but it doesn't matter because we just know that this is the highest point within like of a small neighborhood around it, and this is the lowest point within a small neighborhood around it. All right, and it wouldn't be a bad exercise to graph the original function so that you could visualize that, but you don't have to do that. Okay, so yeah, shorter than that one monster of a video, and you only have the one example for homework, which is right there, and I will see you soon. Bye-bye.